All right, so we are on lesson 8-5. Today's date is Friday, January 24th, 2020. Make sure your name and date are on your paper. We are solving exponential equations. You have that undo button. You have logarithms. So what is our objective today with a quiet raised hand? Beverly had it first.
Use the properties of logarithms to solve exponential.
There it is. So as a review of the main properties that we're going to be using today, if I have log base b of m to the power of n, something special happens with that power of n. Does anyone know that with a quiet raised hand? India?
You're going to take the n and move it in front of the
Exactly. It comes down in front of the log, so it now becomes capital N times log base b of capital M. Thank you. And I'll leave her out. Okay. What about this one? This one is a little bit not intuitive. You have to think about it as a what power function. What power does b need to be raised to get to b? Ellery?
1.
1. That means that I can cancel out a b with a b. All of this basically just crosses off and turns into a 1. If this is being multiplied by something, it's gone. Just get rid of it. That's going to be super, super valuable if I combine the first and the second rule. So do I eventually have an example like that? I do, right here. And okay, yeah, so I have them a bunch. And then finally, what secret base is there if it's log of x? It's log base what of x? Someone that has a card. Someone has a card. Sam.
Is it 10?
It is 10. Log base 10 of x if there's nothing there. And if I say ln of x, I'm really saying the natural log of x. That's log base what of x? Colby. Log base e of x. And what is e? Does anyone remember what e is? You had that presentation where we were going to see how many decimal places of e we remembered, Anna?
The exponential rate of, what should we call it? Growth? No, interest.
Interest, yeah. It's
I think it's 1845?
1828. So 2.718281828, and then you have 45s on each side of the 90s, so 45, 90, 45, and then it keeps going on and on forever. Kind of like pi. You don't have to have all those digits memorized. If you know it's about 2.7, that's good enough for me. All right. So again, we remember this. 2.7, Andrew Jackson. When Andrew Jackson was 90 years old, he had a 45 on each hip. Anyway, strategy for solving exponentials. This is the general procedure that we're going to be doing. So first, you're going to isolate just the base and the exponent. I'll show you what I mean by that in a sec. But first, isolate the base and the exponent. What I mean by that is down here in example 1, I have a base of 10 and a power of 3 to the power of x. Get rid of this 1, get rid of that 2 first by using your normal algebraic properties, right? Add 1 to both sides, divide both sides by 2 to isolate that base and the exponent. Once you have this base and the exponent isolated, then you're going to take the what of both sides? You guys know what I'm talking about. The thing that we've been learning this whole unit. The what? The quiet raised hand. Chewy. What is our whole unit? Unit 8 is unit of, starts with an L. Yeah, take the log. Take the logarithm of both sides, or abbreviated the log of both sides. And then this is kind of the key thing. The reason that I put this rule up here, log base b of b, make sure your base matches with that thing. Make sure the base b and whatever that base of the exponent is, if they match up, they cancel each other out. So where the base of the exponent and the base of the logarithm are the same. Use this second rule that I just talked about up here. Utilize that rule because you get to choose whatever base you want. All right, let's see an example. We have example 1. We're going to round to the nearest thousandth. That means 2 decimal places. No, that's hundredth. So it's 3 decimal places. My bad. I don't know what I'm talking about. 3 decimals. It is indeed 11:50. Skiers, you're out of here. Watch the rest of the video later. All right, welcome back, Anna. You're now watching this video online. Isolate the 10 to the power of 3x. What am I going to do to both sides? I'm going to get more people to come in here. I'm either going to add 1 to both sides or divide 2 on both sides. Which one am I going to get rid of first? This is Algebra 1 now. Going all the way back to like your first week of Algebra 1, I think. Yes, no, Cheyenne. What are you going to do? You have a 50-50 shot. Are you going to add 1 to both sides or divide by 2 on both sides? You're going to do reverse PEMDAS. So add 1, yeah. A and S are on that bottom row, and then finally multiply divider on the next row. So add 1 to both sides, add 1, everyone write it down. When we add 1 to both sides, I now have 2 times 10 to the 3x. That's on the left-hand side. On the right-hand side, I have 26. Emily, what am I going to do next? Something with that 2. Say it louder. You're saying the wrong word, but yeah, you do something with multiply or divide with the 2. Both sides, I do the inverse operation of multiply. Yeah, divide both sides by 2. Divide by 2, divide by 2. And we get now 10 to the power of 3x is equal to 13. All right, so we have now accomplished step number 1. We have isolated the base and the exponent. Here's the 10 to the power of 3x. That has been isolated. There's nothing else near there. Now we're going to use that undo button, the logarithm. What am I going to write here? Log base what of both sides? Quiet raised hand. What should our base be for our logarithm to make it come out really nice? I could choose log base 2 of both sides, and then I'd have to do a change of base formula later. Hopefully we can avoid doing that by doing the correct base here. Is there someone that has a card? I think Sam, you already... Oh, is a question? Yeah.
Yeah, sorry. Isn't it supposed to be 5 since you're dividing them?
Oh, yeah, so the 2 and the 2 cancel each other out. I had 2 on the top and 2 on the bottom. Those 2 just cross off. Yeah, good question. Ooh, 13. What base should I have? Aurelio, go for it. You're trying to use this rule right here. So this number and this number should match up. Well, what is that bottom number? What is this bottom base number that we're trying to get rid of right now? Over here. So is it the 10 or the 3x that we want to get rid of? 50-50 shot. You got this. No, it was 10. So I'm going to do log base 10 of both sides. So it actually kind of helps. I know that I have technology and I can just move it over. But it helps to be able to give yourself some room and say, okay, I'm going to take the log, as Aurelia said, of base 10 of both sides. So that's how I write it. Log base 10 of 10 to the power of 3x and log base 10 of 13. I take the log of both sides. Because Aurelio chose his base of his logarithm correctly, that means now all of this stuff will eventually cancel out. Cancel, cancel, cancel. But weird things happen with this power. Before I start canceling those out, I'm going to use my first property that states, India said, this n is going to come down in front. I'm going to move this power of 3x down in front before I get rid of those logarithms. So I'm going to rewrite this as 3x times log base 10 of 10. On the right-hand side, I'm just going to write this as the log of 13. I'm going to be nice and lazy. I love being lazy in mathematics as long as we can follow the work. I don't have to write the base 10 because we can assume now it's base 10. All right, so from here, I'm going to use that second property where I have a base of the base. That's Ellery's rule that she talked about. What's going to happen with this log base 10 of 10? Quiet raised hand. Who's got this? Ellery already did the rule. Sorry, I have to give it to someone else. Log base 10 of 10. Yes, Jaden. You're so ready to talk. Log base 10 of 10 is what?
I don't know.
Here, I'll give you the rule. Here's your hint. Log base b of b, whenever those two match up, it turns into 1. So log base 10 of 10, Jaden, therefore is?
1.
There it is. So that cancels out essentially. 3 times 1, or 3x times 1 is just 3x. So I ran out of room. Let's come back up here to the
Whatever. Ask her it works.
to the top area. So now I have 3x is equal to log of 13.
Does the
Question, yes.
the log cancels out when we did that before, not just the numbers? Or because it's log of 1, it's just gone.
It's not log of 1, it is 1. 10 to what power is 10? 10 to the 1th
so
power
the
is 1.
log goes away. Okay.
The log goes away as well, yeah, exactly. So just like up here, there is no more logarithm for our second rule. All right, so from there, I need to solve for x. Last step, who's got this? Nice and easy. What do I do to both sides? Who hasn't participated yet? At 0, you haven't gone in yet. What do I do to both sides to get x by itself? By? Yep, there it is. Divide both sides by 3, and there's our answer. X is equal to log of 13 divided by 3. Done. Well, I guess we have to round to the nearest 1,000. Let's get the approximation. So I come back up here to my calculator, and I do desmos.com/scientific. And I have to type this thing in. Log of 13 divided by 3. Zoom in here. Log of 13, all of that divided by 3. And I get 0.371 rounding to 3 decimal places. 0.371. 0.371. Final answer, and box it. Okay. So, this next one I want to do together as well, and then eventually I'm going to let you loose for example number 3. So example number 2. Again, I want to isolate this t, which means I'm isolating this e to the power of 2t first. I'm going to get rid of the 17 and the negative 3. Who can help me do the first step? I think everyone is in now, so we can get oh, Brian, yes. What am I going to get rid of first? The 17 or the multiply by negative 3 using reverse PEMDAS? Am I going to get rid of the addition and subtraction first or the multiplication and division? Take a guess. Subtract 17 or divide by negative 3? Yep, you are correct. It is going to be subtraction because on PEMDAS, and I'm pointing up there to PEMDAS, I go from the bottom to the top of PEMDAS. So let's subtract 17 on both sides. Everyone write it down. Minus 17, minus 17. When we do that, I have negative 3 times the quantity of e to the power of 2t. 2t. And that is going to be equal to negative 3 minus 17. That's really negative 3 plus a negative 17, negative 20. All right, now it's free game. Everyone is in. I can call on people 7 times in a row if I need to. What am I going to do next? Quiet raise hand. Anyone? Beverly. Divide both sides by negative 3. And I now get e to the power of 2t isolated, which was our original goal, is equal to, I'm going to leave this as positive 20 over positive 3. A negative divided by negative is a positive. That's the rule I'm invoking there. All right, now, what am I going to do here? What's our next step? I need to somehow bring this t down into the base. How am I going to do that? Yeah, Ellery.
You'll have 2t log
Log base e, yeah. Log base e of both sides. And you skipped a step also, which is lovely. I'm glad that you know that. That 2t came down in front. So let me rewrite what Ellery just told me, that she said the 2t is going to be down in front. 2t times log base e of e is equal to, and I'm just going to simplify this. Log base e we know is just natural log. So I'm going to say natural log of 20/3. All right, what is our next step? Log base e of e, what is that? Anyone? Log base e of e. India. 1. Yeah, so that just kind of crossed that guy out. That's 1. You can sometimes do an error and say, yeah, that went to 1. Which means our new line, after India simplifies, is 2t is equal to natural log of 20 over 3. Question from Beverly.
Wait, can you like go back a little bit? I don't get where you did the black right.
Black.
How'd you get all that?
So this 2t, because it's a power and I have a logarithm, one of the rules of logarithms is the power can come down in front. So all I did was I moved 2t down in front and then I rewrote the line.
And then where did you get log e? The green?
Oh yeah, so in order to get this 2t to move down, I had to take the log base e of both sides. We chose e because this base is e. We matched these powers. Base and base have to be the same number. So if I take log base e of the left side, I have to take log base e of the right side. Answer the question, or did you want to clarify? Ask another question.
What is that ln right there?
Oh yeah, ln. So log base e is natural log, and that's up here in the notes as well. Log base e is natural log, ln. So I can actually type this into my calculator now. The calculator knows what ln of something is, and I can show you that in a sec once we have our answer almost simplified. I'm just going to type ln instead of log base e. All right, so what is our final step? Easy peasy lemon squeezy step. India?
Then divide both sides by 2.
Yep, divide both sides by 2 to isolate the t, divide by 2. And we get t is equal to natural log of 20/3. And then after I take the natural log, I divide by 2. I'll let you copy that down, and then I will punch that into the calculator. Again, we're going to round to the nearest thousandth, which means I'm rounding to 3 decimal places. So everyone has this written down, and let's come back over here to our calculator. Let's say the natural log of 20/3, 20 divided by 3, and that's all going to be divided by 2. So our answer is 0.94, rounding here to 9. 0.949. 0.949. And again, natural log, the computer knows what that's talking about. This next one will require a change of base formula. So be warned. Do you remember change of base formula from last, or it was yesterday, right? I should probably add that to the notes up here. The answer for this example was 0.949, or natural log of 20/3 over 2. Let me just review. I should have had it up here for the change of base formula. But if I have log base, I don't know, what am I going to choose here? What are my letters? I guess base b of x. Does anyone remember what that is with the quiet raised hand from yesterday? One person remembers, 2 people remember, 3 people remember. Yeah, Sam.
Is it 10?
Ooh, careful. It's log of something divided by log of something. I saw India's hand. Oh, actually, Oscar. Yeah, let's get you in here.
X and B.
There it is. Yep. And you can choose whatever logarithm base you want here. So we just typically choose 10 because it's nice and easy. So that's not the official formula for a change of base formula, but that is a way to start solving it for today's note. So have this written down. It will help you to solve example number 3. All right, good luck on example number 3. I'm going to come and review it in about 2 minutes after you get some individual work time on it. All right, so what was the first step? Quiet raised hand. Who's got this? First step was to Beverly. Divide both sides by -15. And that means that goes away, and I'm left with just the base 3 to the power of the fraction 4w over 5 is equal to 4. What was the next step after this? Quiet raised hand. Do something with a logarithm. Yeah, Ellery?
You're going to move the 4w over 5 to the side. And you're going to have, so it'll be 4w over 5 log base 3 of 3 is equal to log base 3 of 4.
Perfect. And then, yeah, that 4w over 5 comes down in front. And our new equation is 4w over 5 times nothing, because that's all going to cancel out, is now equal to log base 3 of 4. And the problem with log base 3 of 4 is there's no way to do it on the calculator over here. So if I try to do, you can try to do log base 3 of 4, and then it'll be like, nope, this calculator does not support doing a base of another logarithm, which is lovely because I want you to use the change of base formula. If you have like an iPhone, let's see, you can pull out your iPhone right now. No one fell for it? All right, darn. The newer phones do actually have this possibility of doing a change of base number. Beverly, yes.
So for when you do the log, you can put any number in there.
Any base, yes.
So you want to have the same base, like the base is the same.
Precisely, yeah. Make sure that these two numbers match up with one another. Because otherwise the logarithm is still left over and you have to do some special tricks. That's the easiest way to get rid of it. And then finally, to get w by itself, what do I do? Multiply both sides by something, divide both sides by something. Oh, question?
Don't we need to get rid of, make the log into log base 10 else?
We'll have to do that as well too. I was just trying to isolate the W for now.
Oh, okay, well I can answer that.
How do you do that?
You multiply by 5 on both sides,
And also,
divide by 4.
yep, so I could just multiply by 5/4. Multiply by 5/4, which is the same thing as multiply by 5, divide by 4.
Sorry.
All right, so from there, that will cancel out the 4 and 4, 5 and 5, and I'm left with W is equal to. And then I'm going to do a change of base formula as well. Who can do the change of base formula on this logarithm? Beverly.
Log 4
Yep,
over log 3.
log of 3. And that 5/4, I can just attach it on right there. 5 log of 4 divided by 4 log of 3, and there's our answer. Let's go ahead and find what that is on our calculator. I'll give you guys a second to copy down the notes. We get out of here in 30 seconds, so let me do this really quickly. 5 log 4, 4 log 3. I can remember that. So 5 log 4 divided by 4 log of 3. We got 1.577. 1.577. Box it. Final answer. You guys have the entire weekend now to finish the homework assignment. Good luck.